Hunky Beef, a local sandwich shop, has a fixed weekly cost of $525, and variable costs for making a roast beef sandwich are 55 cents per sandwich. We're going to start by writing a cost function, use a cost function combined with a revenue function to create a profit function, and look at that profit function through the lens of our work with quadratic equations. So beginning first with the cost function, we know that we have fixed costs of $525. That amount is not going to change. That would be considered to be things like the labor, the lights, the rent, the kinds of things that you need to keep the business going. And then variable costs are 55 cents per sandwich. The cost of running the business for a week is a direct byproduct of the number of sandwiches that are produced. You have to produce more sandwiches, your costs are going to go up. You buy more beef, you buy more bread. This is work that we took care of a long time ago when we talked about linear functions with cost and revenue. But what if we tried to mix in a quadratic equation? So in this case, our revenue function, which you can see right here, is a quadratic. That doesn't change the work that we are going to do when it comes to creating our profit function. We're still going to take revenue minus cost, but we will have an extra term that back when we did this in the linear form, we didn't need to worry about. So our profit function is going to be our revenue function minus our costs, which we established on the last page. Subtracting out that revenue function from the cost function, subtracting out the cost function from the revenue function, I said that backwards, we're going to leave our quadratic term. 3x minus 0.55x is 245x, and then minus that 525 gives us our final profit function. In our final part, we're going to use the profit function to determine the number of sandwiches it should make and sell each week to maximize profit. Again, if we are attempting to maximize, that's code word for vertex. Our vertex formula, negative b over 2a. We take another look at our profit function. Here's our profit function. Here's our b. Here's our a. So x equals negative 2.45 over 2 times negative 0.001. A little bit of careful arithmetic. You get that the maximized profit number of sandwiches is 1,225 sandwiches. If we then want to determine what is that maximum profit, we go back to our profit function and we use 1225 as our input. Negative 0.001, 1225 squared, plus 245 times 1225, minus 525. And again, you can check my arithmetic on this, but it comes out to 975.63. So Hunky Beef, the local sandwich shop, can expect a profit of $975.63 if they sell 1,225 sandwiches. It's a little bit easier to visualize all of this if you think of the graph. Now, this is a screenshot of the graph. This is not one that we can manipulate, but you might identify a few important points. If they decide to close for a week, that is their expected profit. They've made no sandwiches. They're going to lose their fixed cost of $525. But since they have made no sandwiches, we don't expect any kind of profit or revenue or cost increase or change. It's just going to be that fixed cost of $525. When we get up to about 237 sandwiches is where we would expect the company to break even. That is the minimum number of sandwiches they have to sell to break even, because if you look over here, there's another break-even point over there, but they want no part of that break-even point. We'll get to that one in a second. As you increase the number of sandwiches that you sell, you eventually reach the point where you have a maximum amount of profit that you could make. That is what we found in the last page of selling 1,225 sandwiches. But after that, something interesting happens. As you continue to make and sell sandwiches, you're actually going to see a decrease in your profit. Well, how does that make sense? You're selling more sandwiches, you should be making more money. As you sell more sandwiches, everything else is going to change with it. You're going to need more people to make those sandwiches. You're going to need to run your business longer. You're going to need to pay people more. You're going to need to keep the lights on longer. So it makes sense that there's this point of diminishing return, where if you make a certain number of sandwiches, after that point, you're going to have to start to spend so much more money in order to accommodate that, that your profit actually goes down to the point of, if you made 2,212 sandwiches and were able to sell all of them, you would run into a profit of nothing. And then after that, you would just be losing money because you would be having all of these extra costs and concerns. So the expectation is kind of silly as this looks, you would think more sandwiches means more money. That's not necessarily the case when you use a quadratic model. When you use a quadratic model to do this, you see increase for a period of time, or in this case, a period of sandwiches, and then after a certain point, you get to the spot where it's no longer profitable to continue to make sandwiches at the same level. We can get all of that from our algebraic work, but it's really nice to see it in the graph form, because if you look at it in the graph form, it makes it very obvious where those locations are and how they all relate to one another.